Hey, welcome back to another weekly AI and engineering. I wanted to look at a dynamics problem. I'm doing another dynamics class this semester. I'm just checking, make sure our video audio sounds good. And I thought I would check out if I have kind of an advanced Lagrangian dynamics problem, how does ChatGPT actually respond? And I haven't done this yet. I just kind of work on this stuff once a week now that the semester's starting up. So let's take a look. We'll grab, and I have not tried this at all either. I'm just grabbing a screenshot of a problem and saying, hey, what do you think of this? So I'm going to copy this. Let's see if we can even get the problem into here. Can I just paste it? Oh yeah. So I'm working, and I'll try to describe it a little bit. Lagrangian dynamics problem with two pulleys, 3 block masses, and 2 chords maintaining can't spell today. I want to define equations of motion for the system. All right, so let's see what it comes up with. So it's giving me some kinetic and potential energy, the Euler-Lagrange equation, case B. Y1, Q. Oh, so it read the problem pretty well. So this is what the problem says, is that we are trying to define equations of motion from y, here's y1, so distance to m1, and q1, so they're right there, and then y1 versus y2, so also talking about this second mass here, versus q1, like distance from m1 to m2, and then q2, which is this distance here. And what I'm interested to see is, will we be able to figure out what the constraints are? Use y1 and y2 and their derivatives. Assume chords are inextensible. Yeah. Please set up the constraint equations for variables, and let's come in here. Well, let's just look at the original PDF. So I've got like mass 1, and where's this one? So let me just ask for constraint equations between y1, q1, y2, and q2, since that's all that I have labeled here. Yeah, let's try that. So 1 mass 1 and the system's anchor point. Wow. So this is doing pretty well. Like it's interpreting the picture and figuring out how to do that. So y1 plus q1 is a constant. So let's go in. y1 plus q1. No, that's not constant. y1 plus q1 plus y2 is constant. Why would that one be constant? Anyway, we'll keep going. So it thinks, yeah, I don't know why it thinks that one is true. But anyway, we'll get there. M2 with y2. And here, let's do a side by side. So we've got this. For chord 2. Oh, is it saying? I mean, Q2 plus, yeah, I don't know. Y2 plus Q2. So Y2 and Q2, those are not constant either. I think it's trying to set up equations based on how chords are normally kind of defined. Because here we're getting a transform, so it's taking a picture of what looks like a physics thing, and it's sending that through a transformer, and we're getting results that kind of seem right, like it's setting up constraints, taking derivatives, but it's not really giving us what we want. So maybe if we keep giving it a little bit more information, we could say, we could tell it that actually y1 plus q1 plus y2 is constant, and what else can we say? What else is constant? I don't know what else would be constant there. So let's, can you rewrite the constraints now? Because this, from here to there to here to there, that's always the same distance because it's going up to a mounted point. Chord 2 remains the same, and it's saying M2, M3, Y2 plus Q2. That one is not constant though, because I could have Q2 decrease Y2. Well, one thing that I could do is decrease Y1 and hold this one constant, and now Y2 and Q2 both decrease. Oh, I guess that one's real. Well, Y2 decreases, but Q2 stays the same. I guess that's my problem with that. So maybe if we add some extra things to it. So let's try this. We'll paste this in here. Make it big. And I'll say that this because it's desperately trying to say that motion 2 and motion 3 are the same. So let's delete this and call this Q3, and I'll call this Q2. we'll see if they can actually read my handwriting. So now I've got a Q2 and Q3 that should be the same, and maybe that'll help a little bit with with this things. And should I label anything else? Let's try that. So we'll call that one Q2 and this one Q3. Now paste it. Here is an updated diagram with Q2 and Q3 as positions for M2 and M3. Can you write the constraint equations now? And now I'll put this one over here since this is what we're working on. Okay, so y1 plus q1 plus y2 is constant. I don't know why it keeps trying to tell me that different things are constant. So y2, maybe it's having trouble reading it, but q2 plus q3, that one's a constant for sure. So q dot plus q3 dot, that's true. And so those constraints, those are helping us, because once we have like some constraints, then we can start saying like what the kinetic energy is. Okay, use, okay, one correction, y1 plus q1 plus y2 is constant. Next, give me the kinetic energy of mass of M1, M2, and M3, and pulley 1 and pulley 2. Kind of doing this step by step. Because I know that I need like kinetic and potential energies, and then I can take derivatives of that. We'll see how well ChatGPT does these derivatives. So let's see. We're getting y1 dot, and then q2 dot, and then q3 dot. But this one, these two are equal. So hopefully it's gonna connect the dots there. Q3 dot. Cool. So it did give us like all 5 kinetic energies. So put those kinetic energy terms in terms of, let's say, y1 and q2. Actually, I don't know why. Okay, so q1 dot angular velocity. Yeah, I'm just double checking this equation because I was thinking that this would be like a 1/2 m theta dot squared it's telling me that theta 2 is Q3 dot over R2. And then R2 is the 1/2 M2 R2 squared. Okay, so it seems like it's kind of making sense. Oh, where did the... Oh, it didn't run that one. Just thinking about it, trying to plug some stuff in. Let's see, I've got 1, 2. So I should be able to describe this as like a 2 degree of freedom system. So I should only need, and that's why up here it's asking like define it in terms of either y1 and q1 or y1 and y2, something like that. Because if I have both of those values, then I know what the system is doing. And it's really working hard here, putting all the LaTeX processors to work. And let's see, we have little m1 y1 dot squared, and then big M1, so the disk, it looks like that capital M1 is disk motion, and both of those should depend on that, and then little m2 for Q2, and then little m3 for Q2. Yeah, because it's a negative Q2 dot square, because if this goes down at Q2 dot, this one's moving up at Q2 dot, and they're both Q2 dot squared. And then this 1/4 capital M2, I feel like that one should also have a Y1. All 3 of these should have a Y1 dot, because if Y1 is moving up or down, then all 3 of these are moving up and down. So I don't think it got the velocities correct, because right now it's only, this is a Q2 is a relative term, and we need the velocity in this inertial frame, like velocity with respect to here. I think the velocity of M2, M3, and pulley 2 should include a term for negative y1 dot, since the included terms are relative to the moving pulley 2. Yeah, and it's always so polite, right? ChatGPT, like, oh, you're absolutely correct. But let's see if it actually fixes what we were trying to get it to fix. Q2 dot minus y1 dot. So if y1 is positive, Q2 is positive. So this one could be standing still if this is moving down and that's moving up in the same speed. or could be like relative velocity could be 0, or velocity could be 0. If this moves down, that moves up. And then, all right, so then let's see what we end up with. Here we go. Now we're starting to make a little bit of progress, right? I don't know about this one though, this M2 down here, right? Because now it looks like it's combining the rotational and translational kinetic energies into just one term there. Here, let's see. Tell me how you got the 1/4 m. Well, I guess it does. It tells me up here, right? But it's absolute velocity. So shouldn't there be 2 capital M2 terms? So so we need a y1 minus. Q1 is y1 minus y2. Okay, because the derivatives are all add up to 0. So M1 Q1 dot. What? Shouldn't that be a Q2 dot? Because what I see for this is that we've got, here, I'm going to rearrange camera a little bit. Let's see if we're still. So what I see for this is that we've got this thing can move down. It can move up or down, and the amount that it moves is a negative y1 dot. So if y1 or y1, at least like if I'm calling this positive y1, then this is, then over here this m1 is a negative y1 dot. And then it also has rotation, some kind of like theta 2 dot, where r2 theta 2 dot equals q2. So theta 2 dot is q2 over r2. The disk will use that same capital M2 r2 squared over 2. So kinetic energy is 1/2 capital M2 times y1 dot squared plus 1/2 r2 squared over 2 times q2 dot over r2 squared 1/2 m2 y2 dot squared plus 1/4 m2. And sorry, you might not be able to see that, huh? My face is in the way. And then that the r2 squared cancels out, and then I'm left with that q2 dot squared. So I don't think it's subtracted
And I do think there's a 1/4 Q, or one, if we call it 1/2 M2. So let's jump in here and try to correct it. The kinetic energy for pulley 2 should be 1/2 times M2 times Y1, that should be a Y1, Y1 squared plus 1/4 times plus 1/4 times M2 times Q2 squared. And the thing is with ChatGPT, and this is why I'm always so careful when I'm using this, is that it's always agreeing with me and always just integrating whatever I tell it to, even if it doesn't make sense. Like, it's not checking my math to see, and hopefully if anybody watches this and they want to check the math, they can see, like, does this even make sense? Like, what is he talking about? So let's see. It's kind of going through a little bit of what I was doing. So that same M2 Y1 dot. So it comes to the same result, but it might be because I told it that's the result I want you to get to. And I don't know, probably because now it's got new information that it's kind of folding into the old information. But I do have my terms that I said that I should have. Whether or not that's what I was hoping for is another question. So let's see. Let's go back through the terms, make sure that we're getting somewhere. So M1, if it's moving down, it has kinetic energy, and it doesn't depend on anything else, because Y1 just describes it. M2 down here, that's gonna be, if Y1's moving down, then this is moving up. So I've got that negative Y1 term, and then here I have that positive Q2 term. So there are cases where this is positive, that's negative, and I have zero motion here, but the relative motions are all non-zero. And now I've got this Q3. So in this case, if I have positive Y, Q3 is moving up, and positive Q2, Q3 is moving up. So a negative and a negative. There could be cases where I have a negative but a positive, and now this one's not moving. And then this one is true enough, we just have that, oh wait, but it's Q1. Why Q1? I want Y1 there. Okay, so we are getting close, but pulley 1 should have a Y1 dot term in the kinetic energy. You're absolutely correct. Yes, thank you, ChatGPT. I thought I might be doing... Wait, pulley 1 translation? I don't want translation. I only want the kinetic energy. I think it thinks this is not a fixed... I don't know why it thinks that's not in a fixed location. But it's not considering the rotational energy, it's only considering translational. Man, so you really have to work with this to get you to the point where it's got where it's got like a real something physically meaningful for this kind of physics equation. All right, so it's re-deriving those. Yeah, it's still trying to tell me that if y1, so if this is moving down, then this is also moving up or something. Pulley 1 does not translate, so it only depends on rotational kinetic energy. Yeah, and again, I've never tried just pasting in a physics problem like this where I'm not, in the past, a lot of the things that I've done are paste in like Markdown or HTML to try to work with it, but just using a picture, it's doing an okay job at interpreting like, hey, this is a picture of pulleys, and pulleys in general have some kind of plus minus constraint on them, but it's really struggling to get the specifics of what I'm looking for. Here we go. Now it finally got there. So pulley 2 is moving and rotating, and now, oh, and I've hit the limit. Okay. And that's okay. So I've hit the limit for now. I'm not gonna get the plus, but we made some progress, right? I do have the kinetic energies. Let's see if I can I change the model? Oh, it doesn't like that one. I just want to go back to like mini. Okay, so now I'm on like a mini view tools. Okay, cool. Let's see. I tried to combine all those terms. So total kinetic energy. I got to do another check because it regenerated everything. M1, Y1, M2, Q2, Y1, M3, Q2, Y1, capital M1 is just Q1. That's what I was trying to get rid of. And now M2, so that one should be a Y1. This Y1, that one's right. Okay, so let's try, well, let's just, I can always drop in that Y1 term. And now let's try, yes, please generate the potential energy due to gravity for M1, M2, and M3. Oh, it won't let me. Maybe I really am out of terms here. Might need to upgrade my plan if I'm gonna keep playing around with the latest and greatest, huh? Okay, anyway. This was interesting, just trying to figure out like how well it can interpret these kind of images. I wanted to get to the point where I had an actual differential equation and I could see like, all right, can you show me what I can do with that? Because it should just be that every term in this has some kind of constant acceleration. So then you should be able to solve it with like the kinematic equations for each of these. But I couldn't get there. I hit the free limit for today. Resets at 7:30. So try again maybe next week. Okay, if you were joining, hopefully you enjoyed. I'll keep working on this. Maybe I'll spring for to play around with. Okay, see you next.